the fantasy story says. Now listen to this one. Now the Artemis mission. Listen to what they say. Right? It reached quote unquote escape velocity, because they're going to double speak on this. They're going to say, yes, it has to reach 25. No, it doesn't. I can show you things of both, but whatever. Let's say it escaped, it reached 25,000 miles an hour. Or if you don't like that number, go with 23, right? This is what they're saying now. So it leaves at that speed, then it starts slowing down. Then it goes to zero at a certain point. Now, from 25,000 to zero, then when it starts reaching the moon's pull of gravity, they say, which is another fantasy, starts picking up speed, then it slingshots around the moon and starts coming back, right? And it continues picking up speed until it reaches like 25,000 miles an hour. And then it jets into the Earth's atmosphere, slows down, blah, blah, you know the rest, right? Parachutes. That's what they believe.
So the moon is in the Earth's gravity, but it has its own gravity well.
Yes, correct.
Apart from the Earth's gravity well.
Yeah, but the spacecraft...
Bro, there's like a million...
Whoa, Jeremy.
There's like a million gravity wells everywhere. You're a gravity well. Your mom's a gravity well. Your car, your house, your coffee cup, all gravity wells all over the place. Wells and wells and wells and wells. Like Wells Fargo.
It's like Wells Fargo.
Yeah, and how does it pick up speed? It burns the rocket like for 50 seconds or something. And then it's mind-boggling. They actually believe that the rocket leaves at 25,000 miles an hour, then it slows down as it goes to zero, then picks up speed again. That's what they believe.
I'm not even sure what this is about anymore.
This is about the Artemis moon travel fantasy that you guys believe in. Escape velocity, acceleration, deceleration. Yeah.
This is where you might misunderstanding what they're saying, because apparently what I read is that they get to the stage of orbit first, which is getting to the velocity of 17,500. And then finally, the third and final stage of the Artemis rocket will blast and propel it past the 17,000 up to the 25,500, thereby defeating the gravitational well that you claim that it's in. But the first step is to get into orbit based on the gravity well. That's the two stages that get you there. Then the third gets you past the gravity well, thereby reaching the escape velocity. That's what they say. So
yeah, you're right. They say that they circle the Earth once or twice. I'm not sure, and then they slingshot out. You're right.
Yeah, they say twice. So if you also look at that demonstration,
have you ever seen the diagram Pete Shea draw? The diagram Pete Shea always posts.
Looks like a dick. Got two balls.
Have you seen the one I posted where they have?
That's the path.
Isn't that their whole
that's
thing?
not
It's
all.
sex magic, isn't it?
No, that's not all. When they first put that out, did you guys notice it? I posted it. They had the flat Earth map on that thing. They had the whole continents on with that. The thing that you said that, on the Earth.
Basically, what you're saying is that your whole evidence against the thing is a dick joke. That's it.
Oh yeah, that's Oh, you read us perfect. What this guy's? Are you Nostradamus?
Yeah. Thank you.
That's more where I reside.
I mean, I've just been listening to you, and like you just laughed at it because it kind of looked like a dick. That was like your whole defeater for the whole thing.
You didn't hear the part where I said the escape velocity 25,000 miles an hour.
It's sad because they don't realize that the dick is actually really aerodynamic. All right, that's why it's not. I don't know. It was funnier in my head, but
perfect shape, right? Normal.
Yeah, good try.
It was funnier in my head.
Close your eyes.
Well, yeah,
so
obviously you guys don't know what the Washington Monument represents if you think that's like way far off.
Yeah. I thought it was just an obelisk.
So it's a cylindrical map.
I came in with a joke. You think that they send a craft out there, 25,000 miles an hour, and that craft decelerated to zero, then sped up again, spun around the Earth, and came back? Is that what you? And you're laughing at us? Is that what you believe?
I'm not sure about this deceleration to zero. Can you point that out to me? I'm not sure I understand.
Ask anybody here. Ask any baller here.
I don't want just somebody to say it, right? I want something to tell me that.
Yeah, well, when you get some free time, just Google Artemis and check out the speeds, and you'll see that it decelerates all the way there, goes to zero, then it picks up speed again. I'm not making it up.
The acceleration, yeah, not the speed. It doesn't go to zero speed, right?
Yes, it decelerates. Yes, it decelerates to zero. Yes.
Because it's in a stable orbit at a certain point, so it's not accelerating anymore. And then they do a bit of a burn to sort of slingshot it off.
Oh, so before you didn't know, but now you know exactly what they do.
No, I misunderstood what you were saying. I corrected myself when I realized what you said. You said acceleration, and in my head, for some reason, I was thinking you were saying it went to zero miles, like it had no speed anymore.
Yeah, that's what I said. That's exactly what I said. Yeah.
No, it has speed. It has whatever the speed it is at orbit. It just has no acceleration, meaning it's not
negative. No, negative. You're wrong. It decelerates. It starts off at 25,000 miles an hour, escape velocity. This is your model. I'm not telling you I believe this. And then it decelerates. I have pictures all the way to the trip. You see it going at 18,000, then they show it again, 15,000, then they show it again, 12, 10, 9. I can go on and on. Ask anybody here, bro.
Okay.
Are you maybe thinking about its height above the Earth? Are you confused?
No,
are you
why?
thinking
Why do you got?
Because it doesn't.
I know what you're saying.
Are you confused by it just being in orbit? You think it doesn't move?
You think
because
its
height stays the same?
You think it's traveling at
bro.
You guys think it's traveling at a consistent 25,000 mile an hour all the way to the moon, and it took them 3 days?
No,
but Montreal, are you talking about the height?
I'm not.
No, I'm not talking about the height. I'm talking about the speed that they claim their craft was traveling.
Right, but you're equivocating because at certain points you're saying acceleration, and other points in time you're saying speed, and I'm saying it decelerates to a zero acceleration, but it's still at a particular speed in the
What
orbit.
speed do you think that particular speed is?
Whatever
and another thing
it is to maintain the particular orbit.
Hold on.
Well, much like a let's say the ISS maintains, a particular speed to maintain that orbit. It's not accelerating. It's not going faster and faster and faster, which is what.
So you mean it's not? You mean if it decelerates, it's still gonna maintain the?
If it decelerates, it'll go into a lower orbit, right?
So you understand speed, right?
Yeah.
Well,
Artemis spacecraft.
Speed is relative to something, and acceleration.
Yeah, exactly. How do you measure this? How are they measuring their speed, bro?
Acceleration has nothing to do with speed, right?
How do they measure their speed anyway? Have they got what's the mechanism to measure their speed?
Because it's in relation to a stationary point, which would be its launch, which would be the surface of the Earth. So
what's the instrument that's on the rocket that's measuring their speed?
I'm not sure which instrument they're using, to be honest with you. Whatever measures speed in that sense.
You can see the speed changing and all the time as it's accelerating up to its final velocity to escape the atmosphere.
But I don't know if it's calculated by position or what. I don't, you know what I mean? I don't know.
Okay.
It's not like a car where you're measuring RPMs, right? It's not.
Dude,
hold on. I just posted. So can you give me a second, please? I brought this up. Just 30 seconds, man. We'll solve it. I just posted something, sir, the guy that was talking with me before. Can you please read what it says there in miles per hour? See for yourself, please.
What's the velocity?
Miles per hour. Can you read it? What does it say there?
Well, if I'm looking in the same spot you are, it says velocity 9,325 miles per hour.
Miles per hour. What does that mean? Does that mean 25,000 miles an hour, 17,000 miles an hour, or that mile an hour that's written there? Which is it?
It's the velocity.
Which is what?
But it's 9,325 miles per hour in relation to something, which
exactly
I assume to be the Earth.
Exactly. So now you understand, right? That the speed is in miles per hour that they were giving. Do you understand now?
Yes.
Okay, so if I show you now another picture with a lesser speed, what are you going to say?
I'll say whatever it says. I'm not denying.
Are you still going to say that
anymore.
it's traveling at a constant speed?
I didn't say it was traveling at a constant speed.
Yes, you did. You said it's the same velocity.
Well, look, in relation to acceleration, if you have an acceleration of 0, it means it's stationary or traveling at a constant speed, in which case you can still say the same thing. It's traveling at a constant speed.
Why can't you guys never admit when you're wrong, man? Why? Why is it? What? Tell me
wrong
why.
About what?
Why?
What am I wrong about? Explain it to me.
You said before that this spacecraft travels at a constant speed, 25,000 miles an hour.
No,
And
never said that. Never even once even suggested that.
Didn't you say it travels at a constant velocity? But the speed
I said if somebody tells me that there's 0 acceleration, that the acceleration is 0, that means that it's traveling at a constant speed. I did not say that it traveled at a constant speed at any given moment. I'm saying if you're telling me that this particular thing has an acceleration of 0, it means it's standing still or has a constant speed.
So now you believe that the spacecraft leaves at 25,000 miles per hour, their story.
Show me what you're talking
then
about.
I just showed you a deceleration from 25 to 9. You want to see another one?
What? No,
what do you mean, where?
This is just one picture that says 9,325. That doesn't show a deceleration. That shows a constant speed.
In order for it to...
Show me a deceleration.
You still don't get it, right? I'll show you another picture, but you don't get this picture. That just this picture proves my point. You don't understand that.
Look, a single picture cannot prove deceleration. It can only show what the instantaneous speed is in that moment. So
okay, at what speed does the craft?
Show me either a video or a time-stamped series of photos showing the deceleration.
I'll show you another one, but now just for this conversation's sake, you don't understand that if the craft leaves at 25,000 miles an hour in your story, right, in this thing, and I show it to you going at 9,000 miles an hour, you don't understand that that's a deceleration
in relation to what?
Of 20 of the speed
Look, if you
was traveling when it left. Why are you interrupting me, bro?
It's because the speed would be in relation to something. So if it's
the Earth
is if the Earth is in relation and you're measuring, say, altitude as the example of your velocity, then the initial velocity is going to be 0 as it's on the stand, and then as it launches, it's going to continue to go up as it goes away from the Earth, mostly directly, and as it arches to meet its orbit, it's going to not gain altitude, and so therefore the velocity is going to look like it's closer to 0. It's going to decrease, but the velocity, the speed is going to be whatever it is, like whatever the speed is. But that's
see,
what
you're saying it again. You're double speaking again in the same sentence.
You have to. You can't say these things like acceleration, velocity, speed, and all those things unless you give the relationship. Otherwise,
maybe you're having a hard time hearing.
They mean nothing.
Sir, maybe you're having a hard time hearing. in your model.
You're having a hard time understanding
Please
me.
try not to interrupt me. Let me try to
You
get a
don't
sentence
interrupt
out. I know
me.
you're
I
triggered.
am
I
trying
know
to
your
tell you
model is
something,
under
and you're
attack.
telling me something else.
Listen, dude.
You're not listening to
In
me.
your model, that thing, in order for it to leave, I don't care if you like it. I don't care if you cry or dance. It
Well,
had
you're
to
a
be going
bonehead.
at 25,000 miles an hour.
You
Now,
don't know what you're
sir,
talking about.
it is good. You're going to interrupt me again, huh?
Yes.
Right? I know you are.
Because you're not listening to me.
I'm talking. How could I be listening to you when I'm talking?
Well, because I'm starting to think that you just don't want to listen. So you're willfully ignorant. So why should I have a conversation?
Maybe you should wait until I stop talking. Then you can start talking, and then I could listen. How about that?
Only if you can repeat back to me what I was talking about in the relationship, why it's important to have an understanding of what you're measuring and where you're measuring it from.
You're talking about measuring a speed from a distance to the Earth, right? In relations to the Earth, right?
Yes.
Okay. So the craft that is in question here, that I have here, going at 9,000 miles an hour, give or take, did it leave the Earth traveling? Did it leave the Earth traveling at 25,000 miles an hour in your model? Yes or no?
Yeah, but hang on. Let me just interject real
No,
quick.
don't, please. Do not. No, this is not a time for you to interject, sir. No.
Well, I can try
Did
to
the rocket
clarify.
leave at 25? Please answer my question.
I don't know what the rocket left at because I don't have
Then
the
don't,
evidence to show
bro.
you.
Why are you talking then?
If
talking?
your answer is well, you're telling me something, right? But I have no evidence. So the only thing I can do is take your word for it. So if you're telling me that the rocket is traveling from the Earth, and the Earth is the relationship that we're talking about here, that it's traveling away, the rocket is traveling away from, and it's leaving at 25,000 miles per hour from the Earth, away from the Earth, then I will agree to that as correct.
Okay, so we established that. Now, I show you a picture in your model that it's traveling from 25,000 miles an hour to 9,000 miles an hour.
You didn't show me that.
What do you mean I didn't? I posted you a picture.
You showed me a picture that has 9,325 miles per hour.
Yeah, that's an official
at a certain
Artemis picture. Would you
timestamp.
like another one?
At a certain timestamp for a particular thing.
What?
What's that have to do with the relationship to? Do you know what this 9,325 miles per hour is in relationship to? How fast is it going to from the moon, from the Earth, from it's a different part of the rocket, from the Mars? What
are you
what's
trying
the
to say,
relationship?
dude? What you just want to
What's
talk
the
for
relationship?
talking's sake? What? First, you contended the fact that it decelerated. I prove it to you. Now you're telling me this, and that. Why don't you just sit back, man, and don't talk? If you don't know what you're talking about, maybe it's best not to talk. Did you ever hear that thing before?
So, hold on a second. If I have a car and it's at a start line, right, and then I travel in a straight line away from that start line, right, I can say that the car is going, let's just say 60 miles per hour. It gets up to 60 miles per hour and stops accelerating. It's not accelerating anymore. So the acceleration is 0. The speed is 60 miles per hour. Now, if I am measuring from the start line rather than rotations on the car, and then I turn the car 90 degrees from that start line, I'm still going 60 miles per hour with a 0 acceleration. However, in relationship to the start line, it's going to look like the speed is much slower. Do you know why that is?
I have no idea what you're mumbling on about, bro.
Okay, well, right, because I muddled my description, but in relation to the start line, there's a particular speed the car is going. You can measure it the speed from the speedometer on the car, which is measuring the rotations of the motor, basically, or the wheels, and then giving you a speed. Right, that's what the speedometer does. Or I can use it by a distance judgment and where the velocity of the rocket is, the vector of the rocket, and in relation to that start point, how fast the rocket is moving away from it. And I can give that a speed, okay, which is different than the absolute speed from measured within the car from the revolutions. I don't know how to explain it any clearer because my words are escaping me, but there's two different ways that you can measure that.
I think I may have a better example, right? If I
Honestly,
have,
somebody help me because I'm fucking retarded.
yeah, I got you. I think
You're lost, bro. You're lost.
I'm
And
not lost. I'm just not good at
all
describing.
right, let me get through the example, right? And this could not be what they're measuring, but what I think it is, right? If say I have a ball in my hand and I throw it straight up, right? It doesn't take any kind of curved path. I just throw it straight up in the air. At some point during its trajectory up, it's accelerating as it leaves my hand. It's accelerating till it reaches a max velocity in the upwards direction and a max acceleration in the upwards direction, right? But that's not the height of how high the ball gets, right? It's going to decelerate until it reaches zero, right? For its velocity will reach zero, and that's the height of how high. That's the highest point the ball will get. Then it starts accelerating in the opposite direction towards the ground, and it starts picking up velocity coming with the vector of the velocity in the opposite direction, coming back towards the ground. And I think that may be what they're referencing, like the velocity in relation to its trajectory from the surface of the Earth.
And somehow you think that made sense. Bro,
Yeah,
there's no way
you
around this,
disagree
man.
with how a tennis ball moves through the air? Like,
I
I
don't
don't
care
get
how a
it, man.
tennis ball moves through the air, bro. We're talking about a craft leaving at 25,000 miles an hour and it has to decelerate. That's what we were talking about. Do
Yeah,
you agree
it's
with
the
that?
same thing. It hits a max velocity, the velocity it needs to hit to escape the Earth's gravitational pull to get to the moon. That doesn't occur at the moon. It occurs before the moon, and then it decelerates, goes around the moon, and now it picks up velocity and acceleration in the opposite direction to come back towards the Earth, exactly like a tennis ball going up and down in the air.
No, tennis balls don't do that. No. Tennis balls definitely do not do that.
Yeah, they
Only
just
in your
shoot off
imagination.
into space, apparently.
Nah, there's no way you can. Nah, sorry,
Wait, hold
bro.
on. Tennis balls, they don't do what?
You're now trying to say that tennis balls don't go up and down.
Yeah, they go up and down.
Wow. Okay, so you agree with him then, Essie? Then.
Yeah, I agree with him that a tennis ball goes up and then comes back down. Yeah.
Why did you disagree
Yeah, the
earlier?
rocket has to do the same thing. The moon is the height, the farthest point on its altitude, right? So it reaches the fastest trajectory, decelerates until that acceleration hits zero at its its furthest altitude hits zero, and then it comes back and accelerates in the opposite direction. I don't get how this can be
You got it all wrong,
confusing to
bro.
people.
You don't even know your own model. Let me tell you how it happens in your fantasy
It's
model,
not a
bro.
model, SC. It's how
Let me explain to you
reality
what
works.
happens in your model. Okay, you ready? Your Earth, your mythical ball, is in a well, a gravitational well. Think of it like a soup bowl. Okay? So you got to reach a certain speed to get out of that soup bowl. Okay? So this is what they're saying is happening now. There's a soup bowl for Earth, and there's a soup bowl for the moon, right? So when Artemis leaves, it goes out of the soup bowl when it reaches zero at the edge. then tips over that soup bowl into the other gravity well, whee, and then the moon takes over, right? And then it circles the moon, and then it comes back. That's your fantasy, my friend. The
No,
problem
that's
is,
not
we
even
know your
close.
fantasy better than you do. That's the problem.
That's a horrific
Well, that's
mischaracterization.
exactly how it is. Exactly.
No,
Gravitation
it's
wells.
you're just interrupting me, but that's terribly
I'm sorry.
misrepresenting how gravitational wells work. You don't like climb over an edge. The moon is still in the Earth's orbit. It's not outside of the Earth's gravity well, right?
Never
It's a
said it was.
vector. Yeah, you did. You said it climbs over the edge and goes down into the moon's
That's how
gravity
it's
well.
explained. Yeah, that's how
That-
your fantasy works.
That's
Yeah,
not
goes
how it
from
works.
one gravity well to another gravity well. Yep.
No, I'm telling you right now that that's not how it works.
And I'm telling you, you're wrong.
Right, these are just tensor fields, and they have vectors that have magnitudes, and it's a vector addition problem. There's no climbing up and over the well. You have an acceleration and a velocity vector, and the magnitude of that vector is affected by the gravitational wells that you're in, but you're not climbing over the edge of one and into another. It's just subtracting and adding to your velocity and acceleration vectors.
He's
Yeah,
seeing
look,
it as a
that's
two-dimensional bowl.
I'm explaining
Yeah,
you your
it's
model. When you
grossly
explain, who's
mischaracterizing it.
interrupting me now? In your model, when you show the model, do you not show a trampoline? Do you not show
No,
something in the middle making a well, and then the other thing has its own well? You don't know your own model, bro. It's not
that's
my
only.
problem. You don't under, and you're gonna interrupt me. I know, because it hurts,
You
bro.
asked me a
I know
question.
it freaking hurts. Yeah, I know.
You asked me a question. I was answering it. That
In
would
the
be
middle
if
of
I
the
was
sentence.
trying to just give the simplified version, right? I could present you the actual model, right? I could do out all the tensor calculations and show you exactly what the model is. And it's nothing even close to this little marbles on a trampoline type of thing that you're thinking of, right? That would just be if I wanted to quick and easy give you the concept of what the model is. But in reality, that's not 100% what we think the model is, right? I could do that out for you. We could go through all the calculations and what the tensors mean and what the vectors in the tensors mean. We could do all that.
Dude, in your model, does space and time combine, make a fabric, and does matter curve the time and cause gravity? Yes or no?
No, those are all
No.
just ways of simplifying the model.
Talking to the dummies, right? Like grade school stuff, right?
I've said this on multiple occasions that this whole fabric thing is a gross simplification. It's useful for certain things, but it's nowhere close to the reality of it, right? And this is still simplified because we're just talking words here, but a more accurate way of expressing it is that mass and energy, or mass energy density, will change the trajectory of other mass energy, objects that are around it.
So gravity, now again, they're lying to us because we're dumb, right? They just told us a simplified version. Gravity is not the bending of the fabric of space-time when matter goes near it and warps it. That's not it. That's wrong.
Yeah, I would say if you were to publish in a scientific journal, that's not how you would publish it. You would view out the mass energy density of the larger object and how the path is changed of the smaller object coming in proximity of it. And you'd show the paths, you'd show the lines that represent each path, the math, the values, and the graphical line representations.
Okay, so what makes the path change? How would you explain it if not a fabric bending and causing something to travel in a straight line to curve? How would you explain it?
Yeah, I already did. It's the mass energy density of one object has an interaction with the mass energy density of another object, causing the one, if the smaller object is on a trajectory towards the larger object, it's going to cause the path that the smaller object would take. If that larger object was not there, that would just be a straight path. But if the larger object is there, the smaller object will then take a curved path. It will deviate its
Why is
geodesic
that?
from a straight line.
Why is that? Why will one object, when nearing the other object, change path? Explain to me why, please, in your model.
It's from the mass energy density, SC.
Oh, now it's mass energy density, right? So what exactly are you saying? Mass attracts mass. The density of one mass attracts the density of the other mass. Is that what you're saying?
No, the mass and or energy density of one object couples, right, and that can interact with another object that has mass and or energy density also coupling, and that causes the path to deviate from
by what mechanism? Don't keep saying it, bro. What's the mechanism that does that? The change of path. By what mechanism? What is it?
It's the interaction that they have. The mass energy densities couple to the space-time grid, and they interact.
The space-time grid? That's what I was trying to get you. Can you please tell me what the space-time grid is? What's the space-time grid?
A coordinate system. I already said it's a coordinate system.
So a coordinate system causes something to deviate. That's what you're trying to tell us, intelligent people.
The mass energy density is what causes something to deviate.
What's the mass energy density again?
The mass and or energy density of the object.
Okay, by what mechanism? All objects have mass, density, energy. What's the mechanism that attracts them or causes them to deviate when they approach each other? In your model, sir.
It's an interaction between the two, SE.
Yeah, what? What is that? My God, am I the only one understanding this? Or is he just stringing me along?
Well, what do you want? Do you want me to give like the mediating bosons? They're called gravitons. They exchange gravitons between each other, and that's what mediates the interaction.
Gravitons. Oh, we got gravitons now. Hope everyone's listening. And how do they attract each other? Is it like a magnetic thing, or are they bending and warping space-time? Please enlighten us. These gravitons, what do?
No, they're exchanged between the two objects.
How? Do they shake hands? Is it electromagnetic? Is it a strong nuclear force? What is it?
It's the gravitational interaction. It's the gravity version of those.
My God, bro, you're a smart man.
I'm going to help them out. It's a pressure differential between the two bodies. One exerts a greater pressure than the other. There you go.
They're not electromagnetic objects, right? So they're not exchanging photons. They're not quarks. They're not strongly nuclear coupled. They're not exchanging gluons. They're exchanging gravitons, the mediator of the gravitational interaction.
James, I mean, seriously, bro. I mean, come on, man. Even in a movie, you couldn't come up with a story like that. Seriously.
You're just mocking. You don't have any like actual rebuttal, though. You're just mocking.
What rebuttal? You said graviton, bro. You're not willing to admit any attraction. You're not willing to admit any mechanism. I tell you, is it electric? No. Is it this? No. Is it that? No. And then you say graviton? Like, seriously,
what's
bro?
the mechanism of electromagnetism? Like, what do you mean? I don't understand.
What's a graviton?
I gave you the mechanism. It's the same kind of mechanism as electromagnetism, just with a different particle mediating it. And you're saying that's not good enough, but it's good enough for electromagnetism, right?
So you made up a particle. I mean, tell me.
I didn't make this up.
I'll say, okay, you made up the graviton.
No,
or you discovered
I
it.
did not make up the graviton.
So you're saying there's a graviton?
Well, you asked for a mechanism for exactly how, because you think that's some sort of gotcha. So I'm giving you one of the main ideas that's the mechanism, right? The other three forces, they have their own bosons that mediate those forces, the strong, the weak nuclear, and the electromagnetic, right? So it's not out of line to propose that there's also a particle that mediates the gravitational force. That's what I was giving you, and that would be the mechanism. The same mechanism that the other three forces work by also applies to the gravitational force, because it's kind of special pleading to say that the gravitational force is different for some reason. So that's what I was giving you.
No, you might sound like intelligent, like you know what you're talking about, and you're talking nicely, but everybody knows there's no such thing as a graviton. You just made it up. You probably heard it somewhere. I mean, it's completely ridiculous. Everybody knows the standard model now, believable, is the fabric of space-time. When matter goes near
It's
it, it
not.
warps the fabric. Everybody knows that. You can say whatever you want, bro.
I could
Graviton.
post
My
you.
God.
I could post you pictures of the books that people use to teach gravitation to students and to physicists and stuff, right? There's nothing about any fabric anywhere in those books, but there's plenty about gravitons and things like that. And I will give you, it's not correct to say, right, that the mechanism is mass attracting mass, but that is the overall observation due to this stuff, right? The more massive object changes the trajectory of the object with less mass, causing it to move towards it. I don't know what else you would call that other than one mass moving towards another. But no, it's not the Newtonian mass reaching out instantaneously over a distance and attracting another mass. No, it's not that. But it's still the same observation. That doesn't change.
Well, regardless, you know what I wouldn't do? I wouldn't take a concept of time and space, mash them together, and come up with some cockamamie story, and then go somewhere online and try to pretend that I know what time it is, and this is it. I wouldn't do that. I wouldn't make up stories like that, or certainly I wouldn't repeat them.
Well, I didn't make any of this up. This is, many people have proposed this, and yeah, it's not. I'm not the first one to come up with the graviton thing, right? Sean Carroll has a pretty famous quote that says, you can pretend that gravitons don't exist, but the rest of us physicists are going to live in reality, right? And I hold to that.
Bro, these are the same guys that would readily admit to you that 96% of stuff out there is made up in order for their cosmological model to work. How can an intelligent person like you, right? And I know you know your stuff when it comes to molecules and all that stuff. How can you believe this garbage, bro?
Yeah, because
How?
we're not talking about that other 96% right now, right? We're talking about the regular 4% that we observe around us. And you're trying to say, because they don't know something about this other 96% that has nothing to do with regular baryonic matter, that somehow that means that we don't know something about regular baryonic matter. It doesn't work like that.
I didn't say that. No, that's not what I said.
Okay, then rephrase or restate what you're saying, because that sounds exactly what you were hinting at.
You brought up Sean Carroll, right? And his idea. What did you say Sean Carroll said again?
Well, it's not Sean Carroll's idea either, but he has a famous quote that he says, you can pretend that gravitons don't exist, but the rest of us physicists are going to live in reality.
Right. And I laugh at those physicists because those are the same physicists that come up with these cockamamie stories that dark energy, dark matter, and they get it all wrong and they talk as if they know stuff. So, yeah, I will say that about a guy like that. Absolutely. Why should I believe a word he says? He's a theoretical physicist.
Well,
I mean,
right. That's the difference. That's not how I would approach something, right? I would want to know the reason why they say, why would Sean Carroll say something like that? And because that's how I do things, I want to know, if someone's making a claim, I want to know why they're making that claim. And what do they have that can substantiate the claim? And so when I've looked into this thing about gravitons, do I think it's 100% that's the correct model for it? No, but I do think that it's highly the way that electromagnetism and the weak nuclear interaction have been united and verified, right? I can verify that myself at synchrotrons and cyclotrons, leads me to believe that this graviton thing definitely has a lot of merit to it. Now, overcoming the energy barrier for directly observing them is a different question, but I don't have any reason to believe that it's not a possibility.
but bro, you're intelligent enough to understand that a graviton, which will cause attraction, is completely contradictory to a fabric bending because of mass. It's completely contradictory.
Well,
There's
that's
no
what I
like
was
it's
saying.
not even like close, bro.
That's why I was saying before that this idea of that it's a fabric bending is an okay simplification in some cases, but that's not what is in the like physics journals about general relativity. They're not publishing about trampolines and marbles bending and all that stuff. That's not how it goes, because that's not a good way when you're trying to get to the root of what is really physically happening. That's not a good way to model it, but it's fine to give someone the general concept.
It's not just a general concept. You know how many lectures I've seen from these guys? They all say the same thing, bro. Now, unless they think we're stupid and they're just explaining something to the layman and the general public when they use these terms, but these are the terms that they use. I've heard them talk many times. These Sean Carrolls, Michikakus, all these guys. You know how many lectures I've heard? They all say the same things.
But I see it's not that they think you're stupid. It's just, can you tell me what do I do to get the metric, say like the Minkowski metric? How can I determine the components of it?
It doesn't matter about no Minkowski Schmakowski, bro. Your
Well, that's the
model is
point.
fantasy. There's no numbers. There's no Makowski, Machovskis. That is all bull, bro. You cannot explain away the speeds that they say we're traveling. You cannot explain away gas next to a vacuum. It's impossible. Your model is impossible, bro. It cannot work. There's no amount of math or people that have said stuff that could make it work. It doesn't work.
You're making a bunch of claims now, but they're just diverting away, right? Because you, and it's not your fault. It's not expected of the general public to be able to tell me how I would determine the components of the Minkowski metric, right? But that's why they have to resort to these simplifications of like a fabric bending, because it's something that everyone, for the most part, can understand and visualize in their head. But when you want to talk about Minkowski metric and how to take the infinitesimal of that when there's massive objects around, the regular people he'd be talking to would have no fucking clue what
Okay,
he's
break it
talking
down
about.
for us. Break it down. Okay, fair enough, Jace. Break it down for us dumb people how the Minkowski metric, whatever the hell you called it, can explain a graviton or can explain dark matter or anything about your cosmology. Please enlighten us, dummies. Go ahead.
Well, that's I can't do that in like 2 minutes. See, right?
It's a
I could give you
condition.
the base, right? You can get the components of the Minkowski metric by taking the dot product of the basis vectors, right? And then that tells you information about the coordinates of massive
Get
objects
those
and the
guys. Whoa, whoa,
energy
whoa, slow
density
down, slow down, slow
contained.
down. Where do you get? What did you start off with? You started off with a calculation, an observation. What did you start off with?
You
Like
start off.
what you're talking about, but I'm gonna prove to you it's all bull. It's all theoretic. Go ahead, explain to us. What is it?
You can start off with an object located somewhere, or a
Where?
hypothetical object located
Where?
somewhere.
Where is
It
this
doesn't
object
matter.
located?
It could be on my table. It doesn't matter. But we could say the moon. What do you want to use?
Well, we're talking about out there, right? So let's take a star. Let's take a star. Pick a star, anyone, right?
Hang on, I gotta go for a couple minutes.
Okay.
While he's gone, SC, I could read to you the breakdown that Wikipedia says about the Minkowski metric.
Please, please
It's actually
go ahead.
Minkowski space. Let's go with that. In mathematical physics, Minkowski space, or Minkowski space-time, combines inertial space and time manifolds with a non-inertial reference frame of space and time into a four-dimensional model relating a position to the yield.
Oh, that's the one.
Here, let me put the screenshot. Let me put the link. This is hilarious. Let me put that thing in. It's such gobbledygook. I mean, you know how I got into flat Earth, SE? My friend, who's into science, and really mathematically minded, and he was telling me that his brother and he were baffled that they haven't been able to detect the graviton. So if gravity exists, there has to be a graviton, and it's undetectable, or that it can't. That no one's ever found it, right? I just looked it up. It's still labeled as theoretical, so it's not a thing. It's a thing that you can imagine as a thing, but it's not a thing, And I happened to come upon David Weiss on one of his presentations, and I was like, oh shit. About 2 months later, I went back to my friend. I'm like, I know why they can't detect the graviton. And he wasn't having it, right? He didn't want to hear everything about it. Well, the reason I had for it, there is no graviton.
Okay, now I think I'm starting to remember this Minkowski dude. I think he's the dude that came up with this space-time thing. I think that's the guy that Einstein took it from, if I'm not mistaken. But let's let Jace tell us. I'm dying to hear how this Minkowski thing proves anything.
It sounded like that one spoof commercial. Have you ever seen that one spoof? It's called I'll find the video. This is hilarious. You got to watch this. It sounds exactly what he was kind of doing at the beginning there. There it is.
Yeah, like some
turbo
dude.
encapsulator. You ever seen that turbo encapsulator video? It's just it's like this guy's presenting this like mechanism that has no real purpose, but it sounds so complex, and it's a joke. It's a spoof, He's called the turbo encapsulator, and every word he uses is like that. It sounds exactly
There's a generator. There's a thing that generates words like that, crazy words right after the other. Yeah.
You should watch that. It's like a minute long. You just watch that right now for a laugh while you're waiting for JAce to come back. I'm telling you. Click on what I just posted. And then listen to JAce. It'll sound just like this guy. The turbo encapsulator has to have couplings that are generated through plasma fields that are linked with the space-time field, and Minkowski metric will be determined by the
There's a program that spits out random stuff like that. I forget what it was called, man. A couple of years ago.
That'd be cool to find. I want to check that out. What do they call it? Just the Babel machine?
I forget what a random something or other thing. Yeah.
Random Babel. Random technical babble.
Like these things that they come up with, right?
Oh, techno babble.
Yeah. It's like they think if they can make the words fancy enough, and if they can add mathematics and say Minkowski said this or that guy say that, like who cares who said it, man? If it's
That
nonsense.
seems like that's why he's saying it doesn't matter where the object is. It's all theoretical. Just pick something in, theoretical in on your desk or in space or anywhere, and then we'll start mathematically deriving the possibilities of where it could be and the plausibilities of what that position could mean in the fabric of space-time in relation to all the other imaginary things that go along with it.
Yeah, Jace thinks that he needs 1 or 2 hours to convince me of this garbage. Bro, you can have a lifetime. You're never going to convince me of the fabric of space-time. Never. It's never going to happen. You're never going to convince me of dark matter. Ever. Or dark energy. Ever, bro. Ever.
What about time manifolds?
Yeah.
Time manifolds. Minkowski space is closely associated with Einstein's theories of special relativity. Oh, here we go. And general relativity. And is the most common mathematical structure on which special relativity is formulated. While the individual components of Euclidean space and time may differ due to length contraction and time dilation, in Minkowski spacetimes, all frames of reference will agree on the total distance in spacetime between events. Because it treats time differently to how it treats the 3 spatial dimensions, Minkowski space differs from the 4-dimensional Euclidean space. In 3-dimensional Euclidean space, the isometry group, the maps preserving the regular Euclidean distance, is the Euclidean group. It is generated by rotations, reflections, and translation. When time is pended as a 4th dimension, the 4th transformations of translations in time and Lorentz boosts are added. And the group of all these transformations is called the Poincare group. Minkowski's model follows special relativity, where motion causes time dilation, changing the scale applied to the frame in motion and shifts the phase of light. Space-time is equipped with an indefinite non-degenerate bilinear form. Okay. Space-time is equipped with an indefinite non-degenerate bilinear form, variously called the Minkowski metric. The Minkowski norm squared, or Minkowski inner product. Oh my God, this is hilarious. Oh my God. The Minkowski inner product is defined as to yield the space-time interval between 2 events when given their coordinate difference vector as argument. Equipped with this inner product, the mathematical model of space-time is called Minkowski space. Did I skip? I skipped back.
Is this some satanic spellcraft I'm hearing?
Yeah,
maybe.
it's technobabble.
Well, but the new perspective that for a number of years now, work has been proceeding in order to bring perfection to the crudely conceived idea that a transmission that would not only supply inverse reactive current for use of unilateral phase detractors, but also be capable of automatically synchronizing cardinal grand meters. Such an instrument is the turboencabulator.
Ah, yes, the turboencabulator. I have heard of that, and I'm not studied up myself, but it sounds like you know what you're talking about.
Well, I've been reading up on it, and it seems like the only new principle being involved now is that instead of being power generated by the relative motion of conductors and fluxes, it's now produced by the modal trans-interaction of magneto-reluctance and capacitive diractance.
Yeah, of course. Well, I mean, I could have figured if I was aware of that, then the rest of what you're about to say would really.
Of course, you know that the original machine had a base plate of prefamulated amylite surrounded by a malleable logarithmic casing in such a way that the 2 spurving bearings were in a direct line of panometric fam. The latter consisted of a supply of 6 hydrocoptic Marsal vanes, so fitted to the ambifascient lunar wane shaft that side fumbling was effectively prevented. Anyway, that's enough of that shit.
That makes perfect sense.
That's all fun.
Sounds like It sounds like a theoretical model that has some potential. Or is this something that has actually been built? I think it actually works, doesn't it? Encabulator. What does it actually do again?
They think Minkowski saved them. Blue, you think Minkowski saved you? Come on in. Defend him. I dare you. Tell us how Minkowski explains space-time, curvature, all that. Come on, I challenge you. I dare you. Come on in.
Well, we'll see.
Time
Of course,
manifolds, see.
Of course,
Time
Minkowski space does it.
Tell us, Blue. How does it explain? How does it explain? Go on.
Minkowski's principal tool is the Minkowski diagram, and he uses it to define concepts and demonstrate properties of Lorentz transformations, and to provide geometrical interpretation to the generalization of Newtonian mechanics to relativistic mechanics. For these spatial topics, see the reference articles as the presentation below will be principally confined to the mathematical structure. Oh no, you don't say.
Hey, Blue, I release gas in Minkowski's general direction. And all them whack jobs.
Minkowski gas time.
Yeah.
Here's a quote straight from him. The views of space and time which I wish to lay before you have sprung from the soil of experimental physics, and therein lies their strength. They are radical. Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. Wow. The marriage was made. He also says, it says, at the time when Minkowski was given interpretation of special relativity by extending Euclidean free space to a quasi-Euclidean four space that included time, Einstein was already aware that it is not valid because it excludes the phenomenon of gravitation. Wow. He was still far away from the study of curvilinear coordinates and Riemannian geometry and the heavy mathematical apparatus entailed. Apparatus, SE, it's an actual apparatus now, mathematics.
Yeah.
The mathematical apparatus. That's all you need. Strap that baby on. You got a model. You got a working model. You got a plausible model. Hey, you might as well just call it real.
So an apparatus would have structure, no? Wouldn't it?
Yes, you would think. It's the generalized terming of all these things that they use.
I'm telling you guys, I don't think there's any scientist alive, right, that can go on television, right, with anybody that knows the model and survive. I don't think pick any one of us in here, right, that knows the model. Give us like 10 minutes with the top scientist on the planet. I bet you they would buckle. I bet you they would have to admit out of humility that their model, that there is no proof for this model of theirs. They would have to. They would have to. But you'll never get the chance, of course, right?
But you don't think that the space of the bilinear maps forms a vector space which can be identified as M?
Only M series.
So that the example of non-inertial coordinates in Minkowski space-time.
Yeah.
Or the Born coordinates, yeah. Another useful set of coordinates are the light cone coordinates, yeah. Because the Minkowski inner product is not a inner product, since it's not a positive definite, i.e. the quadratic form, need not be positive for non-zero, v the positive definite condition that has been replaced by the weaker condition of non-degeneracy. Can you believe that?
Yeah, he thinks because he can say Minkowski space-time, that changes Einsteinian garbage space-time fabric. He thinks that somehow he said something there. Oh, you don't know Minkowski space? You don't know that Minkowski equation? Yeah, I laugh at it. You know why?
Yeah.
Because it's nonsense.
Well, because I know it's nonsense because the Minkowski metric n is the metric tensor for Minkowski space, which itself is a pseudo-Euclidean metric, or more generally, a constant of the pseudo-Riemann metric in Cartesian coordinates. As such, it is the non. I could go on all day. Let's see. I could go
But
on all day.
wait, Snack, you forgot about that. And an orthogonal basis for Minkowski space necessarily consists of one time-like and three space-like unit vectors. If one wishes to work with non-orthogonal basis, it is possible to have other combinations of vectors. For example, one can easily construct a non-orthogonal basis consisting entirely of null vectors called a null basis.